Okay, factoring ax squared plus b plus c. You've already been, remember, you've already been factoring trinomials. They have not had the a number in there yet, but we've been able to take a binomial and a binomial and factor that out of that one long trinomial already. And so in here, it's the same thing, same process, except that we are kicking it up a notch with a nice little letter right there called a, which is going to put a coefficient in there, like the 6. And so we're just going to have to, a little bit extra stuff. So to give you an idea of what it's going to kind of look like, the start of the answer, the start of the problem and the start of the answer, what are we looking at? You're going to get something like 6x squared plus 22x plus 20. You're going to take that and you are going to turn it into 3x plus 5 times 2x plus 4. And so, and a little bit extra there, but I want to talk about that in just a second. You can see that if I take the 6x squared right here, the 6x squared, what are some numbers that will get me to 6 that I can multiply? What are some factors? 2 times 3 or 3 times 2. I put it 3 times 2. I could do 6 times 1. That's all I got. I got the x. X times x gives me the x squared. So if I multiply 3x times 2x, I get 6x squared. The other thing I'm looking at is this, the c value right there. What are some factors of 20? 20 and 1, 10 and 2, 4 and 5. I went ahead and just put 5 and 4 right here. 5 times 4 is 20. And then this last factor right here, 22x. Well, perhaps you can see that if I use these numbers right here and do some products with them, multiplying right here, the product, I'll probably come up with 22x. What do I mean by that? Well, if I took 3x, and I decided to just, if I did 3x times 4, 3x times 4 is, forgot to do that, 12x plus 2x times 10, 10x, you would see that I get 22x right there. So if I just looked at what I did first up here at the top, 3x times 4, you remember doing the outers on FOIL, and 5x times 2, the inners from FOIL, you would come up with 22x, and you might remember that's how we got that center term when we did trinomials just a lesson ago. So let's go back from, we have a really good start right here, to is that complete yet or not? And it is not, because we are not factored out as far as we can go. And what I mean by that is this. 3x plus 5 times 2x plus 4. There are no more factors. These are both prime numbers. 3 and 5 are prime, no more factors except for 1. But I can't take anything else out of there. I cannot bring a 3 out of 5 or a 5 out of the 3. But if I look at 2x plus 4, I know that 2 is a factor of 4. I can take this 2 out of the parenthesis and pull a 2 with it, and I can write it like this. You'll remember, and I'm just going to show you, make a little block right here. You'll remember doing the distributive property. 2 times x, 2x. 2 times 2, positive 4 right there. So nothing more than going backwards, really using the distributive property backwards. So I factored out of 2 out of this binomial. So now I have 3x plus 5. And now I'm going to have I factored the 2 out, so the 2 is right there by itself, and the rest of this comes down as x plus 2. And I'm going to rearrange that so it's in proper math syntax. Okay, syntax. The 2 is going to be here, and then we got the parentheses for this binomial and the parentheses for that binomial. 2 times the factor of 3x plus 5 times this other factor, x plus 2. Three factors is the way this one actually worked out. A lot of times you're still only going to have 2 when it's simpler. This is an advanced problem right here, but I wanted to introduce you to this, and so that you're able to handle not only is it going to be a binomial, but we're going to finish it out, and we're going to have three different factors. In fact, I could actually, if you're more comfortable, you could do that too for now. So it looks like you can see 3 different quantities are being multiplied against each other. All right, so here's an example. Same example. I just want to show you, all right, what's the method? How can we get there? And I'm going to take the 6x squared plus 22x plus 20. And we're going to do some trial factors. Trial meaning, you know, I'm going to try to come up with some numbers that they may or they may not work out at all. So what am I thinking? Well, I know that I can take for the first one, I decided to take the 6. What are some factors of 6? I know 6 times 1. I know 6 times 1 is 6. I know 3 times 2 is also 6. And then I used it down here again because I'm going to show you in a second why I have extra, these are extra trials down here. But anyway, 6 times 1 or 3 times 2 will give me the 6 right there. So that's how I got the x's. This is 1x. 6x times 1x gives you 6x squared. Or 3x times 2x also gives you 6x squared. I'm also thinking about some trial factors of 20. So I was thinking, well, 10 times 2 is 20. I'm thinking 4 times 5 will work. Also, 20 times 1, those are factors. And I went ahead and I took these two and I turned them around. So I have 5 times 4 or 4 times 5. Either way that works out. I could have 1 times 20 and I could have 2 times 10, but I kind of ran out of room there. But I think you get the point from that. So how do I test? The way I test for each one of those is to find out who's the lucky binomial times binomial there that's going to work for this. And I know you already saw in the beginning that it was this guy, but what we're going to do is we're going to see how to use this to find out the middle term, 22x. So I'm going to test this one right now. Remember, I'm just going to multiply the inners and the outers and add them up. So here's what happens. I multiply 10 times x and I get 10x. 6x times 2 gives me 12x. 10x plus 12x is 22x. Hey, I like that. 22x, beautiful. Well, what happens here? 4 times 2x, 8x. 3x times 5, positive 15x, that equals 23x. Isn't that interesting? Remember on the first one, we had 3x. We know that this one works, but it does not work when I switch. It doesn't work when I switch those around. What happens here? 6 times 1, 6x times 1, that gives me the 6x. Sorry, I went backwards. 20 times x, 20x. So 20x and 6x make 26x, and that doesn't work. And then down here, when I test this, 5 times 2x, 10x, 3x times 4x, 12x, 10x plus 12x, 22x. So we've got 2 answers. We've got 2 answers right now that will actually fit this. Or do we really? Example 1, continued. I went ahead and took our first option, 6x plus 10 times x plus 2. Remember, 6 times 1 and then 10 times the 2, and we had the 22x. So we knew that worked. And then I also put our other option up here that we knew that would work. And here's what happens. If you remember, I have to look at this and say, okay, did I factor out everything yet? Here, I only have 1 and 2, which are prime numbers. Yes, I did. I did factor everything there. I can just bring it down. Can I factor anything out of here still? I have a 6 and a 10, and I know that 2 is a factor of both of those, which means a 2 has to come out. I got to pull a 2 out from both of these. So I write my 2. 2 times what gives me 6? Okay, 2 times 3x, that gives me 6x. 2 times what gives me the 10? So 2 times 5 gives me the 10. And now I have a factor of 2 that I can't pull out anything else out. It's done. I have 3 and 5, so I have this quantity, this binomial, that's been totally factored out. There's both prime numbers, so I'm done. And this is also prime numbers here, so I'm done. So this is the answer. 2 times the quantity of 3x plus 5 times the quantity of x plus 2, and that's the answer right there. Over here, and I kind of went through this on the first part, but just to show you again, 3x plus 5 comes down, no more to factor out. Here, remember, we can factor a 2. We can factor 2 out of that, and we get our 2 times x plus 2. Rearrange this so it's in the proper syntax. 2 times this quantity, and you can see that those are equal. Excellent. All right, let's do, we're going to do another example, a little bit simpler this time. I've just have some single digit here to just kind of show you what would happen. I've got 2x squared plus 7x plus 3. And I start to think of my trial factors. So I write out some trial factors, the words. I set up, I probably should have showed you this, but I set up my template. So I've got blank binomials. And I look at this first term right here, 2x squared. Factors of 2 are 1 and 2. 1 times 2 is 2. So I'm going to have a 2x and a 1x. 2x times 1x gives you 2x squared. So that's where those came from. Now I look at this constant right here, or the c, can I do that? The c value. Factors of 3 and 1. Well, 3 is already a prime number, like 2 was. So I can use 1 and 3. I'm going to go ahead and just put the 3 right there and the 1 right there. And because everything is positive, everything stays positive right there. Well, I'm thinking, you know, before I did this other step, I'm thinking right here, I'm like, wow, that looks pretty good right now. Why don't I just test it to see if I can get the 7x? So let's just see what happened. I come over here, and remember, we multiply the inners, 3 times x, 3x. The outers, 2x times 1, 2x. 3x plus 2x equals 5x, and I'm trying to get 7x. Darn. So we're going to have to do another trial factor over here. So let's see what happens. I still know I can't do anything but a 2x and an x. There's nothing I can do with that. But I could take the 3 and the 1 and I can reverse them. I can flip these. So now I took the 1 and put it in that position, the 3 in this position, and let's see what happens. I'm going to multiply the inners. 1 times x is x. 2x times 3, 6x. So x plus 6x is 7x, and we get a star. We get a star for that one. That is the correct factoring of this trinomial right here. And so I just brought it down here. What, you know, it would be 2x plus 1, that quantity, times the quantity of x plus 3. And that would be correct. All right, time to go for it. I'd like you to pause this and go for it right now, and I'm going to go ahead and work it out. On number 1 right here, remember, we're going to just try to think of some trial factors. And then I'm going to think about how to find the middle term. I'm just going to do MT right there. Okay, again, I'm looking, oh yeah, draw the skeleton. Okay, I know looking at the 2x up here, that's prime number. That has to be a 2x and an x. No choice. That's the easiest thing to start off with. Now I'm going to take a look at the 3, and again, I've got the same situation. I'm going to go ahead and put the 3 here and the 1 there. And let's just find out what happens if, let's see if I got it right off the bat. Multiply the inners. That's a 3x. Multiply the outers. That's a 2x. That equals 5x. 5x and the middle terms equal out. That's great. All right, we got it right off the bat. So the answer to this is 2x plus 3 times x plus 1. And we can verify, did we really get all the factors out? Well, look at it. This is a 1 and that's a 1. Prime is 1. We're done. 2 is prime, 3 is prime. So yeah, we got everything out of that one. Number 2 over here. Let me see, I guess I'm doing this in green. I'm going to abbreviate trial factors on this side. Draw my skeleton. And middle term. This is my test for middle term. Okay, now we have a 3x squared. Prime numbers of 3, 3 is a prime number, so we have 1 and we have 3 to work with. So we're just going to go ahead and 3x it right there and an x over there. 3x times x, 3x squared. Wow, this is like, we just did that over there. So it's going to be, I'm going to go ahead and I'll try 3 there. I always try the bigger number in the first one first. Why not? You never know what's going to happen. And then we're going to go ahead and see if we got the, I need 10x for the middle term. So this is going to give me 3x. And this is going to give me 3x times 1. That's also 3x. That's a 6x. Not yet. Let's do it again. Put the skeleton there. Look, I know this has to be that. There's just no question. The only thing I can do is swap those 2 numbers right here. So let's try it out. It's going to work. All right, here we go. Inners, outers. 1 times x is x. 3x times 3, 9x equals 10x. And we are good to go. So the answer is 3x, x times x plus 3. And that is the end of this lesson. I'll see you in class. We're going to stop it right here, and we're going to work on these a little bit, and then we'll move on to some subtraction type problems.